Yes. Quite. I say, old chap, have you ever heard of the history of Newton's laws? Why, yes, of course. But, our dear viewers, have they? You see, it all began with our good friend Aristotle, back in the year whenever he lived BC. Aristotle stated, incorrectly of course, that weight must affect the speed of falling objects. Unaware of the force known as friction, he incorrectly stated that you also need a constant force to keep an object moving. Then, we had our good old buddy Copernicus. While he never said that Aristotle's theories were wrong, his heliocentric model of the universe showed that Aristotle was not, in fact, infallible. Next, there was Galileo. Galileo also performed his Galilean accelerator, one which an infamous physics class from Milwaukee, Wisconsin so lovingly recreated. He also debunked Aristotle's false theory of the weight of falling objects in his famous experiment where he dropped a musket ball and a cannonball off the top of a tower, and much to the surprise of everybody involved, they both landed at the same time. Just before Isaac, we had René Descartes. René essentially stated that all objects that are not moving will stay doing the same thing that they are currently doing unless acted upon by another object. They cannot move without some force acting upon them. Object of rest tends to stay at rest unless another force acts upon it. And then, on Christmas Day, 1642, the great Sir Isaac Newton was born. Newton, for his first law, essentially just rewrote what René had stated back in 1644 when he was but a young wee lad, that all objects that are at rest must stay at rest unless acted upon by another force. All objects that are moving must stay doing so unless they are acted upon by another force. Isaac even admitted that he could only do what he did because he stood upon the shoulders of giants. And for his second law, Newton brought out the heavy article. It had already been stated that force was related to motion, but Newton really quantified this relationship by adding in the element of acceleration. Newton was such a tank that he literally created differential calculus to help him define acceleration. Finally, Newton developed his third law, that every force has an opposing force equal in magnitude and opposite in direction. Force pairs, as demonstrated in this instructive video.
We are Group 64 and this is physics. This is Group 64 and this is physics.
But an easier way to measure equal and opposite forces, as well as the equation force equals mass times acceleration, the second law, would be to measure the force acted by a person on the ground, otherwise known as normal force.
Today we're going to be finding the normal force of Tim. Tim's mass is 230 pounds. Gravity is 9.81 meters per second squared, and the conversion from pounds to kilograms is 0.435 kilograms per pound. Force equals mass times acceleration. Weight equals normal force. Normal force equals mass times gravity. The weight of Tim is 0.453 kilograms per pound times 230 pounds times 9.81 meters per second squared. The weight of Tim is 1,000 22 newtons. I weigh a kilonewton. I'm not sure how I feel about that. Since weight equals normal force, Tim's normal force is 1.02 kilonewtons.